The goal for this video is to successfully make a request to the Yelp API and get data back. What I have here is an empty Android Studio project. I haven't changed anything. You can see that when I run the project, I get hello world. The very first thing I'm going to do is Android apps have a permission model. And so in order to use the internet, which of course we do need the internet because we're talking to a web service, we need to add in a user's permission line in the Android manifest. The next thing we need to do is add in the libraries that will allow us to talk to the API. Android has some low-level primitives for making network requests, but this pattern of making an API call is so common that there are dedicated libraries to do that. So the one that we're using is called Retrofit. Retrofit is a really popular Android library that allows your app to talk to an API such as the one provided by Yelp. So there's a lot of terminology I'm going to throw at you, but don't worry too much if you don't know all the details. The takeaway is that Retrofit makes it much easier to do network calls by removing a lot of the low-level details. So you can see here from the guide, it's a type-safe HTTP client for Android and Java. What I actually find more understandable than the Square documentation is the code path documentation. So if you just Google for code path Retrofit, you should come to this article. So the very first thing that's required is you need to add some dependencies into your project. So just copy these 3 lines and open up the build.gradle file, which is located in the app module. Paste it in and then tap on sync now. And what's happening when you tap on sync now is that it's downloading all of the code relevant for these libraries. So you can actually start referencing this in your project. And just to demystify this a little bit, the JSON is an example of a converter. A converter is what takes the response from the API and converts it into a Java or a Kotlin data class. And so we're going to be using JSON. There are a couple other options here, but we're using JSON. And then here are the actual libraries for Retrofit. Scrolling down a bit, there are some notes here about what to do on the upgrade path. We're not upgrading anything, so let's skip all this. And then there's a section here about creating Java classes for resources. So Java is very verbose, much more verbose than Kotlin. And so there's actually a shortcut that allows you, if you're creating a Java class from JSON, to kind of shortcut the process. But we're going to skip this because in Kotlin it's actually much, much easier, which I'll show you. To come down to this section, creating a retrofit instance. This is the first thing that we'll want to do. The way this works is we'll use the builder coming from the retrofit library, add in a base URL, add a converter factory, which in our example is going to be JSON, and then call .build in order to actually get the instance of retrofit. The first thing we want is a base URL. So in our example, the base URL is going to be https api.yelp.com/v3. So going into Android Studio, go to main activity, and at the very top, I'm going to define a constant called base URL. And actually, at this point, even though I haven't actually written any interesting code, I'd like to run the app because I want to make sure that the app is still able to compile after having added these libraries. Let's make sure, yeah, we still see hello world. So that's a good sign that we haven't gotten off track yet. So retrofit.builder, and then add in the base URL, add in the converter. Going back to the guide, the next step is that we want to define the endpoints for our API. The way we'll do this is simply by defining an interface. So what that means is we're going to define a class which doesn't have any implementations for the methods. We're simply defining the method signature. So we're talking about the method name, parameters, and return type. And then Retrofit will be in charge of actually filling in the details for this interface. That's the benefit of Retrofit. So I'm going to go back to Android Studio. Let's create a new interface. I'm going to call it Yelp service. The return value of the method that we're going to define is always parameterized by call and then the type of what we're getting back. In addition, every method has to be annotated with the HTTP verb. So in our example, the only thing that the Yelp API is allowing us to do is read data, which is a GET request. We need to also fill in the endpoint here. So let's go back to the documentation, and then the endpoint is businesses/search. So I'm going to say get businesses/search, and then function search restaurants. And if you recall, there are 2 parameters that we will pass into this endpoint. First will be term, which is a string, and the second is a location. And so the way this works with Retrofit is we're going to describe these as query parameters. And so I'll copy this term and we'll say query term, search term. You can call the name here whatever you want. And then one more query will be location. And the return type is always going to be surrounded by call. And I don't want to worry actually about what the details of the call are. So for now, I'm just going to say any. So now that we have the Yelp service defined, we can actually start referencing it in main activity. So say retrofit.create and pass in the class instance. It's a Yelp service : class.java. And now this will return to us the Yelp service. And now we're able to call this method search restaurants on the Yelp service. We'll pass in a search term. So the search term will search for avocado toast. And the location will be New York. At this point, the natural question is to ask, how can we get access to the data which is being returned from the Yelp API? Because underneath the hood, this search restaurants call is using the internet to talk to the Yelp server and getting data back. This is where there's an important distinction between synchronous and asynchronous programming. In synchronous programming, which is what most of us are comfortable and familiar with, when you make a method call, you get back the result of that method call immediately. For example, like in this line. Or if this search restaurants call was synchronous, we'd expect to get back some sort of value, like restaurants, immediately. And then we could do whatever we want with that restaurant. However, if you look at the return type here, we're actually getting back something of type call. Search restaurants is asynchronous, which means that the method call here might take an arbitrarily long amount of time to finish, either succeed or fail. Whatever code is after this line, we want to continue executing that as soon as we fired off the network request. When the network request finishes, we want to get called back and get alerted of that and, for example, update the UI. So network requests are one example in Android of many examples, for example, database requests, where you can't expect the operation to be immediate. And when the operation is not immediate, you can't hold up the main thread or the UI thread because that's really important for user interaction and for the app to continue processing user input. So the way we can do that here is by on the call object, we can enqueue it, and then we need to pass in a callback. So we'll say object and pass in a callback, and callback is parameterized by a type, which is what we have given as the parameter here. So we're going to say any here. I'm going to let Android Studio help us with this. There's two methods we need to override: on failure and on response. So my pattern, I just typically prefer to have the on response above the on failure. Let's add in a log statement. Okay, at this point, let's try running the app. And we don't expect any UI changes because we haven't actually modified the XML UI file yet. But what we expect is we should have gotten either a success or a failure. So let's filter for main activity. And what I'm seeing is a 400 response code. And if you Google for what that means, you can see that 400 means a bad request. The server cannot or will not process the request due to something that is perceived to be a client error, meaning that something on our end, as a mobile app developer, we did something wrong. And if you'll remember, Yelp API has a requirement for an API key. This is for tracking and authentication purposes. And so that's our issue. We need to pass in an API key. Save this as another variable. And if you go to the documentation about authentication, you can see how to authenticate API calls with the API key. All we need to do is set the authorization HTTP header value as bearer followed by the API key. I'll add this in as the first parameter to our search restaurants interface. This is going to be annotated with header. The value is going to be exactly authorization. And I'll call this auth header, and this will be of type string. And so now the responsibility of whoever calls this method is to pass in the auth header. So let's go back here, and the first parameter needs to be the bearer followed by API key. So I'm going to pass this in, and the API key should refer to the constant that we've defined. So hopefully now we will get into the on response and actually get proper data back from the Yelp API. In order to better inspect where we're stopping and what the data is at that point, I'm going to put breakpoints inside the method bodies. And instead of running the app like normal, I'm going to go up to this bug icon and Debug App. What this will do is start the app like normal, but as soon as we hit one of these breakpoints, as the app boots up, execution will pause. We're able to inspect each of the parameters here. So now if I go into response, the code that we get back is 200, which is great. That means that we got an okay response. And if you look inside body, we are able to see a JSON object, which has businesses, total, and region, which is exactly what we expect given the documentation. Students always have some issues here. If you encountered a operation not permitted on failure, I found that that can usually be easily remedied just by uninstalling the app on your emulator or on your phone and then reinstalling it. Also, double check to make sure the spelling of all the parameters is correct. So make sure that you have bear correct with one space in between bear and API key. Make sure you've copied the API key correctly and the base URL is correct. And also, of course, if you have any misspellings here, that might also cause a failure. So once you have that working, the next step is parse the results and actually turn them into Kotlin data classes.